Okay, kids, we're back here, section 3.4, practice question 3. And it says, determine the appropriate coefficient of friction in each case. So 3A, it says it takes 59 newtons of horizontal force to get a 22 kilogram leather suitcase just starting to move across the floor. So when you see just starting to move across the floor, when you see that phrase right there, that's telling you the object's not moving. So that's telling you you're going to be calculating mu s, static friction. That's what you're going to be calculating. And so we're going to draw the free body diagram here in our given. So there's the force of gravity, which is also known as weight, and we know the equation for that. That the force of gravity near the surface of the Earth is equal to the mass of the object times the gravitational field strength near the surface of the Earth. The object is on a floor of some type, so there's the normal force, which because of the horizontal nature of this is equal in magnitude but opposite in direction to the force of gravity. Next, we've got the applied force, okay, or the pushing force, whatever you want to call it. Let's call it FP for push, okay? And then we've all tried to get something moving as we're pushing it along the floor. Friction is working against us. And in this case, the object is just starting to move, so it's FS, S for static, okay? Now, what's really important here, well, a lot of things are important, but this is also important, is that it's not moving. It's just about to start to move. So that means its acceleration is, it's not moving, it's standing still. Amy? 0. Okay? And they want us to calculate, our required here is mu s, the coefficient of static friction. That's what they want us to calculate. Well, I'm going to write A for analysis because there's only one equation. There's only one equation that I know that has mu s in it. Here it is. So if I'm going to solve for it, I'm going to write this equation down because I know that's the only equation. Let me write that again. That's a horrible F. This is the only equation that's got what I'm solving for in it. That's why I circled it there. It's the only equation that has that in it. So I need this particular equation. Now I'm going to rearrange this equation to isolate for the variable I want to solve for. Right? And that would be, then we would have mu s is equal to the magnitude of the force of static friction. Right? All over the magnitude of the normal force. So let's recap here. You've got this object right here. It's not moving. It's being pushed, but there's a force of static friction working against it. We even know how much FP is. They tell us. They tell us that the force of push is positive 59 newtons. They tell us that in the question. The positive I added because I like that positive being forward. Okay, so they tell us that. All right. And then we realized that mu s is what we want to solve for, the coefficient of kinetic friction. And then I said, this is the only equation that's got mu s in it. So I better write it down. If I'm going to solve for the coefficient of static friction, I better write down an equation that has that value in it. And I do that. So that means if I want to solve for the coefficient of static friction, I need to know what the force static friction is, and I need to know what the normal force is. Let's continue then. Luckily, I remember that normal force is equal in magnitude but opposite in direction to the force of gravity. Remember that? So I'm going to substitute that in there. Notice I still have the magnitude signs, meaning whatever is in the numerator and whatever is in the denominator are going to be positive. I have these magnitude signs. Okay, well, let's continue. Luckily, I remember the equation for the force of friction. I still have to carry my negative sign. I can't make it disappear. It's still there. But isn't this the equation for the force of gravity? Yeah, so I plug that in. So that leads us to looking at this and say, well, do I know the mass of this leather suitcase? We do. It's 22 kilograms. We know the mass of that. Do we know the gravitational field strength near the surface of the Earth? Yeah, we know this. Negative 9.8 newtons per kilogram. So we know the denominator completely. Now we need to work on the numerator. Now we need to work on the numerator. So I need to think of an equation. I need to think of an equation that has force of static friction in it. What equation would have force of static friction in it? What equation would have force of static friction in it? Well, here it is. Watch. F net is equal to force push. That's a horrible F. Let me fix that. Force push plus force static friction plus force gravity plus normal force. Oh, look, I found an equation that has force static friction in it. I need to solve for that. Good. It's good that I found an equation that has it in it, right? That's a good thing. Look at these horrible F's I'm making. Horrible. I just get too excited. There we go. I don't know why, but I do. Okay. Well, luckily you remember that these two cancel out, right? Because we're on a horizontal surface. Next, I've told you kids in this class and in other videos, as soon as you write down F net is the sum of all forces, there's another corresponding equation which must always be written down along with it. I told you it's the heart of solving many of these problems. Whenever you write down F net is equal to the sum of all forces, you must also write down F net equals ma, Newton's second law, the most important equation in physics. Okay? All right. Do we know the acceleration of this object? Do we know the acceleration of this object? We do. The acceleration of this object is, anyone in this class know what the acceleration of this object is? Is the object moving? Amy, it's zero. The acceleration is zero. It's not moving. Which means then F net is zero. If the acceleration is zero, then net force is zero. That's very powerful. Because now I can take the fact that F net is zero, I can take the fact that F net is zero and put it right in here, 0 newtons. Oopsie, let me fix that. Don't know why that's happening. I'll fix it though, don't you worry. There we go. I can put that right in here. Look, 0 newtons. There's no net force is equal to the force push plus force static friction. You see that? Now, remember what I'm doing here. I want to find force static friction because I figured out what the denominator is, but now I had to figure out what to do with the numerator. Don't forget, don't lose sight of this. Well, look, kids, if I bring this to the other side, it becomes negative. Negative force push is equal to force static friction. Aha. Aha. So now I can take that, go back into here and say, look, this is equal to negative force push, magnitude of that, all over magnitude negative mass, acceleration due to gravitational field strength near Earth's surface. Look what I have now. Do I know the mass of this? Do I know M? Yes. Do I know what planet I'm on? So I know the gravitational field strength. Yes. Do I know the pushing force? Yes. And now you can finally substitute and answer. Now, you kids that are in class, listen to me. Put your pens down. Did you see how many steps I had to go through? I'm telling you right now, because you've taken physics, so I'm assuming you want to continue in this area. The days in your academic life, the days of, I write down the equation, there's 3 variables there, there's 3 symbols, there's 3 quantities. Mr. Zafiro in the question gives me 2 of them. I do a little rearranging, and I solve for the 3rd one, which is the unknown. Those days are over. The days of 1 step and it's done, I'm done my homework, it's done. That doesn't exist for you anymore. This exists. Many, many, many steps and coordination and logic and organizing. That's why, do you see now why I gave you grass? Okay, this is logical thinking, mathematical reasoning. This, if you're going to continue in this line, this is your future. Many people who have sat in those seats have had great success at this, moved on to become engineers, scientists at this very school. And the only way they got there was persevering, working hard, letting me help them, ask questions. Okay, they're not any smarter than you, but they gave it a really good effort and they let me help them. Okay, did this help you? Okay, bye kids.